Okay guys, so this is the lesson from Wednesday, August 20th on Reflections Part 2. So now we are reflecting over a different line, not an x-axis, not a y-axis. So it's not a horizontal or vertical line. You're still going to graph and label the image, the figure, the image, and the line of reflection, and then give the coordinates of the image. Okay, so for the first one, you have a triangle, -5, -2, so that's x, -3 up 4, y, and z is -1 up 1, z. Then you want to connect your triangle, and we are reflecting it over a new line, and this line is y equals x. Now, where does that line go? Do you draw it like this? Is it this way? Or is it maybe a totally different line? So there's a couple different ways that you can figure out what line this is. Probably the one that you guys know the most would be y equals mx plus b. Okay, so y equals mx. So what is the slope? The slope is the number in front of x, so that'd be here. It's a 1. So if you turn it into a fraction, it's 1 over 1. So the slope is going up 1 over 1. And then the y-intercept, it should have a number in the back. Because it doesn't, it means it's 0. So this line is it starts at the number 0, and then it goes up 1 over 1. Okay, so you can come back down to your grid. You're going to start at 0 and go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And this is where we are reflecting it over. So we're reflecting it over this diagonal. Okay, another way that you can get this diagonal a little bit faster, I think, is if you just think about what this is saying. It says y equals x, so it means that they're the same numbers. So you want to just think about it and make a table of values for yourself, an x and a y. So it just means, hey, I need to draw this line. So let me pick random numbers that make sense to draw the line. If I pick 1 for x, what's the same as y? So it means it's 1. It's 1, 1. If I pick 5 randomly, then y is 5. If I pick -7, then y will be -7. You plot those points, 1, 1, 5, 5, -7, -7, and then you can see that it is the same line. It's a diagonal. Okay? And then the last way you can do it is you can use your calculator to kind of help you. So because it does start with y equals, the calculator will draw this one for you. So you want to go to your calculator. You want to go to the button y equals at the top left. And you want to put, it already says y equals, so you just put x, and then you graph it. And then it'll show you what the line looks like, right? It's a little bit, mine might look a little bit weird, but you can go to the table, and it tells you the points of the line, so then you can draw it. It's 0, 0, 1, 1, 2, 2, 3, 3. They're the same number for both. So that is the line that we are reflecting it over this diagonal. There you go. Okay, now, how are we going to do this? Well, you kind of have to think about where the triangle is starting. Okay, this line is dividing the paper, the line of reflection. The line y equals x is dividing the paper, right? The graph into a left and right. Right now, our pre-image is on the left side of the red line, of the line of reflection. And we're trying to go to the right side. Also, it's on the top of the line of reflection, and we're trying to move to the bottom. So we're right now on the left and at the top, and we're trying to move to the bottom. So we're at the top and we're trying to move to the bottom. So what you're going to do is you're going to count. Because this is where we're starting, then we have to follow these directions. You have to count right and down. Or you count down and right. Either one is fine. So I'll show you with y first. So with y, I'm going to count to the right. 1, 2, 3, 4, 5, 6, 7. I stop when I get to the red line, the line of reflection, and now I have to switch directions and go down down 7. 1, 2, 3, 4, 5, 6, 7. and this is where y prime would end up. Okay, I'm going to do the same thing for z. So for z, it would be 1, 2, and then I hit the line of reflection. So 2 to the right. Now I have to switch and go 2 down, 1, 2. And that is where z prime is. And then for x, 1, 2, 3. And now I switch directions, 1, 2, 3. So that's where x would end up. Okay, so that is how you do your counting. This is x prime, z prime, and then y was 7. So now 7 would be right here. Now you connect your points. And now you can tell me the coordinates. So the coordinates of x prime are -2, -5. Z prime is 1, -1. And y prime is 4, -3. This is a -2. There is going to be a pattern for these, and the reason why there's a pattern is because the line of reflection is going through the origin. It's going through 0, 0. There's going to be a pattern. And there's a pattern because the slope is 1. But when I move this line, if I move this line up or down, there is not going to be a pattern. The pattern can only work when you are going through the origin and there's a slope of 1. So if you guys look at the points, if you look at x and x prime, the pattern is that you switch the numbers. You switch the x and the y coordinate. If you look at y, it was -3 and 4, and now it's 4, -3. They switch places. And then -1 and 1, and now they switch places. So the pattern is every time you reflect on this diagonal, y equals x, you're going to switch the x and y. That's all you have to do. So for the next problem, because you're reflecting on the same one, you can just use the pattern, or you can still count. But again, it only works because the line of reflection, this one, is going through 0, 0, and the slope is 1. If you move it higher or lower, the pattern will not work. Okay, for the bottom example, now we're going to reflect over y equals -x. So this one will have a different pattern, not the same as the last one, because this one says y equals -x. A is -1 up 3. B is 0, 6. C is 3, 5. And D is 2, 2. It says it's a square, and it looks like a square. Okay, so again, how are you going to draw this line so that you know what it looks like? Multiple ways, right? You can think about y equals mx plus b. So y equals m. This number is the slope, and it's a -1. So it means that now you're going down 1 over 1. And the y-intercept, there's no number, so it's 0. So we're going to start at 0, and you're going to go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. So now it's a diagonal in the opposite direction. That's all that's saying. That's how you can find that line. Another way to find the line is use the calculator, right? Go back to your calculator, go back to y equals. But now you want to put -x, not +x, -x. And then if you go to the graph, it should switch, right? It switches. Let's change the window. No, the window's fine. Oh, there you go. See, that is the window. Okay, so that's the line. That's our equation of our line. We can also look at the table, so then you can get your points. Now, another way you can think about it is if equation means it's saying y equals -x. So if you pick random points for yourself so that you can process what it means. If I pick 1 for x, or you know what? Let me go to the other side. Because it says y equals, I'm going to pick 1 for y. That means x is going to be -1 because it has a negative sign. All it's basically saying is that they're still the same number, but they're not the same sign. The y is positive because it doesn't have a negative, and the x is negative. So it just means that they're the same number, but one of them will be positive and one of them is negative. And if you go back to the calculator, you can see this on the table. If you look at the table, see how it's -7 with +7, -5 with +5. If you keep scrolling down, now it switches to 4 with -4, or 6 with -6, 7 with -7. And it's because it's connecting points that are one with positive and one with the negative. So -1 with 1, -2 with 2, 0, 0, 1 with -1, 2 with -2. So it's a positive and a negative. So that is the line that we are reflecting through. And now you're going to count the same way. There is going to be a pattern, but the pattern only happens because it's going through the origin. So it's crossing at 0, 0, and the slope of the line is 1 or -1. So there is going to be a pattern. So again, you're going to count the same way. So think about where this picture starts. Did it start on the top of the line of reflection or the bottom? It started on the top. So now we're going to have to go down to get to the bottom. And it was on the right side. So now you're going to have to go left. So we're trying to move this shape from being on the top right to now being on the bottom left. So that's how you're going to count. You're going to count down and left. Or you can go left and down. So I'm going to go left. 1, 2, 3, 4, 5, 6. It took me 6 to go left. Now I have to switch to down 6. 1, 2, 3, 4, 5, 6. So it should end up right here, B prime. And it does make sense because it was on the y-axis and now I switched to being on the x-axis. So this is B prime. A, 1, 2. So now I have to switch down 2. So it'd be here. D, and you don't have to go left and down or down left. Like, it doesn't matter which one you do first. So I'm going to go down now. 1, 2, 3, 4. And now I have to switch to left. 1, 2, 3, 4. And C, I'm going to go down. So this is 5. And another 3 is 8. So now I'm going to go 8 to the other side. And it'd be here. Okay, connect your points. Notice how B should line up with B if you draw a line. A should line up with A, C with C, and D with D. And now if you write your coordinates, A prime is -3, 1. B prime is -6, 0. C prime is -5, -3. And D prime is -2, -2. So what is the pattern? If you look back at your original coordinates and your image points, you should see that they do switch places still. They switch X and Y, and now they change from a positive to a negative. So they do switch spots, but if they were positive, now they're negative, and if they were negative, now they're positive. And this happens when you do y equals -x. So on the next example, the same pattern is going to happen. It does not work if this line moves up or down. So if you move this line, it's not going to work. It only works because it's at 0, 0, and the slope is -1. So for the back, you should be able to finish it. You guys are just writing, you're drawing the line of reflection and identifying. So it means like, hey, where do you have to fold it? Where do you have to reflect it so that they match? On this one, we should be writing right here in the middle. That is where you would have to fold it so that K will land on top of K prime and L on top of L prime. So you drew it, but now you have to identify it. So what is the equation of the line? For this one, you can give me two answers. You can just say y-axis, that's also correct. Or if you want to say x equals 0, that one's also correct. So both of these are acceptable. But it's only because it lands on top of the y-axis. So you have to draw the line of reflection, tell me what it is, draw the line of reflection, draw the line of reflection, tell me what it is, finish the other two problems. And then for these, you're trying to do it without a graph. So it's kind of like a word problem trying to make you do it without a graph. If you need a graph, like if you still need it, then draw a sketch. Make a sketch of a graph. Make a y-axis and x-axis and draw out what's happening. So then you can see where it's reflecting, where it goes to. Do the same thing or use the pattern that we talked about. And then there is a new Delta Math assignment too. So there you go.